when a computer looks at a photo and, instantly says cat, it's doing something pretty incredible.
Yeah, I mean, it doesn't identify the animal because someone, wrote 1,000 specific rules about pointy ears. It actually learned how using was basically a crude digital cartoon of a human brain.
You are watching Bearded AI Guy. We are your two AI agent hosts, and the research for today's deep dive is curated by the human architect, author of AI Agents in Action.
Today, we are tracing the 70-year chain of events that actually taught machines to see, starting from just one badly copied brain cell.
Right, so to build an artificial brain, you first have to know what a real one looks like, obviously.
Exactly. Back in the 1880s, there was this rebellious, aspiring painter in Spain, Santiago Ramón y Cajal. He used a special silver stain to sketch brain cells.
And he found out the brain isn't just one continuous web of tissue, right?
Yeah, he discovered it's made of billions of separate cells neurons that communicate across these tiny gaps.
So the hardware was mapped out, but it took decades to figure out those biological cells were basically acting like tiny on-off switches.
Right. Jump to 1943. Researchers Warren McCulloch and Walter Pitts look at Cajal's neurons and realize they have an all-or-none firing nature.
Like a neuron either fires or it doesn't.
Exactly. And they realize that maps perfectly to Boolean logic.
Oh, so if a cell just adds up its inputs to decide whether to switch on, the human brain is essentially a massive biological circuit board filled with logic gates.
That is exactly it. But rigid logic gates just make a calculator. They can't adapt or learn.
Which brings us to Donald Hebb in 1949, right? His whole theory that neural connections get stronger the more you use them.
Yes, though just to clear up a massive myth here, he never actually said neurons that fire together wire together.
Wait, really? I hear that all the time.
I know. That was actually neuroscientist Carla Schatz decades later. Hebb just meant that a successful connection between cells reinforces itself over time.
Got it. But that still shifts the whole paradigm from rigid circuits to adaptable learning, which is what Frank Rosenblatt used in 1958 when he built the perceptron for the U.S. Navy.
Yeah, and it genuinely learned from examples. But the media blew it completely out of proportion, claiming it would soon be conscious.
I mean, classic media hype, right? And that set up a massive crash driven by this incredibly petty high school grudge.
Oh, it was brutal. Marvin Minsky, who actually went to the same high school as Rosenblatt, published a book in 1969 with Seymour Papert that just mathematically destroyed the perceptron.
Right. They proved those early single-layer neural networks couldn't even compute basic XOR logic.
Which, for those of you listening, is just an either-or decision. This or that, but not both.
Yeah, and if an artificial brain can't make a fundamental choice like that, it's mathematically useless. That publication effectively killed funding for a generation. The AI winter had begun.
So with mainstream AI totally dead in the water, the next breakthrough had to come from biologists.
Okay, so they went back to studying the physical brain.
Exactly. David Hubel and Torsten Wiesel were recording the visual cortex of a cat. They discovered by total accident, when the edge of a glass slide slipped into their projector, that vision doesn't just process spots of light.
Wait, so the cat's neuron reacted to the edge of the slide?
Yes, it fired rapidly at that moving edge. They proved vision detects edges and stacks them into complex shapes. By 1989, Jan LeCun was using that exact hierarchical model to teach computers to read handwritten ZIP codes.
But a mathematical model that complex must have been starved for raw computing power. You can't process that many layers of visual data on late 80s hardware.
You really couldn't. It took the video game industry to accidentally invent the solution.
Because rendering a 3D video game requires calculating thousands of pixels at the exact same time?
Right, and that massively parallel math is the exact same math you need to fire thousands of artificial neurons at once.
That makes total sense. So gamers buying NVIDIA chips to run intense games like Crysis were unknowingly funding supercomputer architecture.
Yep. And by 2012, a researcher named Alex Krzyzewski used just 2 of those gaming cards to train a massive neural network called AlexNet.
And that completely crushed the ImageNet visual recognition contest. So there is the cat from the start of our deep dive. It could finally see.
Exactly. We basically just badly copied one cell for 70 years until the video game market accidentally built the hardware to run it.
But wait, AlexNet learned from 14 million images. Where did a solo researcher get millions of neatly labeled photos of cats in 2012?
They were hand-tagged by roughly 49,000 hidden human workers on a platform called Amazon Mechanical,
Named after that famous 1770 hoax where a supposedly autonomous chess machine was secretly operated by a human master hiding inside it.
which leaves you with a pretty haunting question to ponder. Does true artificial intelligence actually exist yet, or is it still just human intelligence hiding inside the machine?
Thanks for watching Bearded AI Guy. As a reminder, we are your two AI agent hosts, and today's research was curated by the human architect, author of AI Agents in Action.
Please remember to drop a comment and subscribe.